So, what is the national grid and why does it matter? To understand this, we need to look at the blueprint of the system that connects homes, industries, and the entire nation.
It all begins here at the power generation plant. Power is generated from the plant at 15 kilovolts, but this voltage is not nearly enough for long distance transmission. So, the power goes to a step-up substation. Here, transformers boost up voltage from 15 kilovolts to 330 kilovolts. Why? Because the higher the voltage, the less energy gets lost along the way. Next stop, transmission. This is where those giant towers and high voltage lines come in. They carry electricity over hundreds of kilometers, connecting power stations in the north, south, east and west through the national grid. At this stage, the voltage stays high at 330 kilovolts, so the electricity can move efficiently across the country. Once the power gets closer to the cities and towns, it reaches another set of substations. Here, the voltage is reduced or stepped down from 330 kilovolts to 33 kilovolts, and then again to 11 kilovolts for neighborhood distribution. From here, your local distribution companies or discos takes over, sending the power through smaller lines into the communities. Finally, electricity makes its last stop, your homes and workplaces. But before it gets there, another small transformer nearby steps the voltage down once more, this time from 11 kilovolts to 240 volts, which is the standard level your appliances use safely. And that's it. From a roaring turbine at a distant power plant to the quiet hum of your ceiling fan, it's all part of one continuous system called the Nigerian National Grid. As Nigerians, we know the feeling when the lights go out. But not every blackout is a grid collapse. Sometimes it's load shedding, a controlled power cut to prevent overload on the grid. A grid collapse is quite different. It is sudden, unplanned, and shuts down the entire country in seconds. To understand why collapses happen, we need to understand balance. The grid operates at 50 Hz, a measure of how synchronized generators are with power demands. When such supply matches demands, the system runs at exactly 50 Hz. But when something disrupts this, a plant trips offline, a transmission line fails, the frequency shifts. If it drops too low or rises too high, protective systems automatically shut everything down to prevent equipment damage. This event triggers a cascade. A plant going offline forces others to quickly pick up the load. If they can't handle it, they trip too. And within seconds, a single fault ripples through the network and the entire grid collapses. So why does this keep happening? The causes are interconnected, but a few stand out. First, inadequate generation. Nigeria generates between 4,000 and 5,000 megawatts on a good day, but the country needs about 30,000 megawatts. And with so little buffer, there is no room for error. Second, gas supply issues. Most power plants run on natural gas, but supply is inconsistent. This is due to pipeline vandalism, maintenance problems, or even contractual disputes. And when gas flow drops, turbines shut down. Third, aging infrastructure. Many transmission lines and substations date back to the 1970s and 80s. Decades of limited maintenance means failures are more common. And remember, a single fault can trigger a chain reaction that can lead to a grid collapse. Finally, limited transmission capacity. Even when the power is generated, the grid often can't move it efficiently. Bottlenecks create imbalances that destabilize the entire system. When the grid collapses, restarting it isn't simple. Power plants need electricity to start, but with the grid down, that electricity is unavailable. This is where the black start generator, which is the backup generator for power plants, come in. Certain stations, usually hydroelectric plants like Shiroro and Kainji, can restart without any external power. These stations provide the initial spark, And from there, engineers at the National Control Center carefully synchronize each generator, stabilizing the frequency and then reconnecting the transmission lines, delicately and carefully waking up the collapsed grid. This entire process can take hours and sometimes even a full day. So what is being done to fix these problems? Stabilizing Nigeria's grid requires long-term investment, modernization, and reforms. On generation, efforts are underway to diversify the energy mix. New solar farms across the north, wind projects along the coasts, and upgrades to hydroelectric dams are underway. The goal is to reduce gas dependence and build a renewable powered grid. On transmission, the Transmission Company of Nigeria is expanding the network. New 330 kilovolt lines are reducing bottlenecks. Aging substations are being replaced with automatic systems that respond faster to faults. Regional interconnections are strengthening too. Through the West African Power Pool, Nigeria is building ties with neighboring countries for cross-border electricity trade and backup supply. Reforms are attracting private investments, and with the right policies and funding, Nigeria's grid can evolve into a modern, resilient system.
The story of the Nigerian national grid is far from over. Yes, the light still flickers. Yes, the grid still collapses. But with every new power plant, every upgraded line, Nigerians are one step closer to a stable grid. And because when the light stays on, industries grow, hospitals function, and families live with dignity. That is the future worth fighting for. And it begins by understanding the system that powers it all. This is Silicon Blueprint. And until next time, subscribe, like, and share.